Examining electrical installations, especially those found at fairgrounds, involves several critical steps and considerations. Because there is no image available, I'll focus on a general approach to fairground electrical inspections. Firstly, it is essential to conduct a thorough visual inspection. This includes checking for any signs of wear and tear, such as cracked or damaged insulation, loose connections, and corroded components. Pay close attention to wiring, conduits, and junction boxes, ensuring that they are properly installed and secured. Secondly, verify that all electrical equipment is properly grounded. Grounding is crucial for preventing electrical shock and ensuring the safe operation of electrical devices. Use a ground tester to confirm that grounding systems are functioning correctly. Check the grounding electrodes and connections to ensure they are intact and free from corrosion. Thirdly, evaluate the wiring and cable management systems. Look for any instances of overloaded circuits, undersized conductors, or improper wiring practices. Ensure that cables are properly supported and protected from physical damage. Pay particular attention to temporary wiring setups, as these are often prone to hazards. Fourthly, inspect all electrical panels and distribution boards. Check for proper labeling of circuits, adequate clearance around equipment, and the presence of arc flash protection. Verify that circuit breakers and fuses are correctly sized for the loads they serve. Ensure that panels are free from moisture, dust, and other contaminants. Fifthly, review the overall electrical system design and documentation. Verify that the system complies with applicable electrical codes and standards. Check for any modifications or alterations that may have been made without proper authorization. Ensure that accurate records of electrical installations and maintenance are maintained. Sixthly, use appropriate test equipment to assess the condition of electrical components. Perform insulation resistance tests to detect any insulation breakdown in wiring and equipment. Use a voltmeter and ammeter to measure voltage and current levels, ensuring that they are within acceptable ranges. Use a thermal imager to identify hotspots or areas of overheating. Seventhly, focus on identifying potential hazards, such as exposed wiring, damaged equipment, and unsafe working conditions. Take immediate action to mitigate any hazards that are identified. This may involve repairing or replacing damaged equipment, correcting wiring errors, or implementing safety protocols. Eighthly, consider the specific electrical needs of the fairground. Fairgrounds typically have a wide range of electrical loads, including lighting, amusement rides, food vending equipment, and temporary exhibits. Ensure that the electrical system is adequately sized to accommodate these loads. Pay particular attention to the power requirements of high-demand equipment. Ninthly, review the National Electrical Code, NEC, and any local electrical codes or regulations. Ensure that all electrical installations comply with these requirements. Stay up to date with the latest code changes and revisions. Consult with a qualified electrical inspector or engineer if needed. Tenthly, pay special attention to temporary electrical installations. Temporary installations are often used for events such as fairs and festivals. These installations must be installed and maintained in accordance with applicable codes and standards. Ensure that temporary wiring is properly supported, protected, and grounded. Use ground fault circuit interrupters, GFCIs, to protect personnel from electrical shock. 11thly, ensure that all electrical equipment is properly labeled. Labeling should clearly indicate the voltage, current, and power ratings of the equipment. It should also identify the location of circuit breakers and disconnect switches. Proper labeling is essential for safe operation and maintenance. 12thly, check for the presence of emergency lighting and backup power systems. Emergency lighting should be provided in areas where people may be present during a power outage. Backup power systems, such as generators, should be available to supply critical loads during an outage. 13thly, review the maintenance records for the electrical system. Maintenance records should document all inspections, tests, repairs, and replacements. These records can help to identify potential problems and track the performance of the electrical system over time. 14thly, consider the age of the electrical installations. Older installations may be more prone to problems and may not meet current safety standards. If the installations are very old, it may be necessary to upgrade them to meet current codes. 15thly, inspect the grounding system thoroughly. The grounding system is a critical component of the electrical system, providing a path for fault current to return to the source and tripping the circuit breaker. Check the grounding electrodes, grounding conductors, and equipment grounding connections to ensure they are properly sized and installed. 16thly, verify the integrity of the overcurrent protection devices. Circuit breakers and fuses are designed to protect electrical circuits from overloads and short circuits. Check the circuit breakers and fuses to ensure they are properly sized and functioning correctly. 17thly, inspect the wiring insulation. The insulation on electrical wiring is designed to prevent electrical shock and short circuits. Check the wiring insulation for any signs of damage, such as cracks, cuts, or abrasions. If the insulation is damaged, the wiring should be replaced. 18thly, examine the electrical connections. Electrical connections are points where wires are joined together. These connections can become loose or corroded over time, leading to electrical problems. Check the electrical connections to ensure they are tight and clean. 19thly, ensure adequate clearances around electrical equipment. Electrical equipment requires adequate clearance for ventilation, maintenance, and safety. Check the clearances around electrical panels, transformers, and other electrical equipment to ensure they meet code requirements. 20thly, inspect for any signs of water damage. Water can damage electrical equipment and create electrical hazards. Check for any signs of water leaks, flooding, or condensation. If water damage is present, the electrical equipment should be inspected and repaired by a qualified electrician. 21st, verify that all electrical work is performed by qualified personnel. Only qualified electricians should perform electrical work. Verify that the electricians are licensed and insured. 22nd, ensure compliance with the Americans with Disabilities Act, ADA. The ADA requires that electrical equipment be accessible to people with disabilities. Check the height and location of electrical equipment to ensure it is accessible. 23rd, review the electrical safety program. The electrical safety program should outline the procedures for safe electrical work practices. Ensure that all employees are trained on the electrical safety program. 24th, conduct regular safety audits. Safety audits can help to identify potential hazards and ensure that the electrical safety program is being followed. Conduct regular safety audits of the electrical system and equipment. 25th, document all findings. Document all findings from the electrical inspection. This documentation should include photographs, measurements, and recommendations for corrective action. 26th, follow up on corrective actions. Ensure that all corrective actions are completed in a timely manner. Follow up to verify that the corrective actions were effective. 27th, maintain accurate records. Maintain accurate records of all electrical inspections, tests, repairs, and replacements. These records can be used to track the performance of the electrical system and identify potential problems. 28th, continuously improve the electrical safety program. The electrical safety program should be continuously improved based on the findings of inspections, audits, and incident investigations. 29th, consider the specific hazards associated with fairgrounds. Fairgrounds can present unique electrical hazards such as temporary wiring, crowds of people, and exposure to the elements. Take these hazards into consideration when inspecting the electrical system. 30th, stay up to date on the latest electrical codes and standards. Electrical codes and standards are constantly evolving. Stay up to date on the latest codes and standards to ensure that the electrical system is safe and compliant. Some additional points to consider include checking the size and type of conductors used for various circuits to ensure they are adequate for the intended load, referring to NEC Table 310.15 for ampacity ratings. Evaluate the condition of the surge protection devices, if any, to ensure they are functioning properly. Inspect the lighting fixtures and lamps to ensure they are in good condition and properly installed. Confirm that all electrical enclosures are properly sealed to prevent the entry of moisture and contaminants. Verify that all flexible cords and cables are approved for the intended use and are not damaged or frayed. Ensure that all extension cords are properly sized for the load and are not used as permanent wiring. Assess the overall condition of the electrical equipment and look for any signs of deterioration or damage. These steps, in general, should provide a sound electrical safety practice.